Yeah. So students, I already explained some basic concepts of chemistry chapter through my presentation. So now we'll see what kind of questions can be asked from this chapter. So mostly you'll get numerical questions on this chapter, and let's see how we can solve the questions based on this without wasting too much time on that. Okay, and we'll also see some kind of shortcuts how to solve the questions within the minimal time. Okay, so now let's move to the first question. One part of an element A combines with two parts of B, which is another element. 6 parts of element C combine with 4 parts of element B. So if A and C combines together, the ratio of their masses will be governed by. The options are given are law of definite proportion, law of multiple proportion, law of reciprocal proportion, and the fourth one is law of conservation of mass. So here you can easily eliminate this option, the fourth option, that is the law of conservation of mass. No, this is not related to the law of conservation of mass. So any one of these 3 options, A, B, C, might be the correct one. So let's see which is the correct one. So one part of an element A. So A is an element and which is combining with 2 parts of B. So the ratio of A and B in which they are combining is equals to 1 by 2, right? And similarly 6 parts of C is combining with 4 parts of element B. So element B by element C, it is 4 parts and it is 6 parts, which is equal to 2 by 3. Okay. So if A and C combines together, the ratio of their masses will be governed by. So if here A is combining with B, here B is combining with C. If A and C, if they combines together, then the ratio of A and C is governed by which one? If you recollect, it is governed by the law of reciprocal proportion, which we have learned that if 2 elements A and C and combining with the same mass of other element, so this ratio, the ratio in which A and C combines between these two, so this ratio is governed by the law of reciprocal proportion. Okay, so this is the C is the correct option. It is not law of definite proportion and it is also not law of multiple proportion. So here option C is the correct one. Okay, so you can also solve this question without doing all this, just by looking at the question. That is, law of definite proportion is definitely not going to the answer for this, because here we have element B and element C. We have 3 different elements and we are talking about the A and B is combining and B and C is combining. Okay, so it's not going to be law of definite proportion. So it may be law of multiple proportion, it may be law of reciprocal proportion. So there is a competition between B and C. You can stick to the answer C, because here the 3 elements are involved. In multiple proportion, only 2 elements will form 2 different types of compounds. Okay, so if any question, if 3 elements are involved, then you can simply put option C. Okay, the law of reciprocal proportion. So it's a theoretical question based on the laws of chemical combination. Okay, so let's move to the next question. Yeah, this question also seems to be based on the law of chemical combinations. So let's see. Hydrogen combines with chlorine to form HCl. It also combines with sodium to form NaH. If sodium and chlorine also combine with each other, they will do so in the ratio of their masses as. The 4 options are given. Okay, so let's decode the problem. Let's see. Let's try to decode the question and let's understand what is the question is all about. So here the hydrogen is the common element between these 2 compounds. So one is sodium hydrogen and other is chlorine hydrogen. So sodium and hydrogen are combining with each other and they are forming sodium hydride, which is an ionic hydride, and chlorine and hydrogen are combining with each other and they are forming HCl. So here two different elements are combining with the same mass of the third element. Okay, so the question is, if the sodium and chlorine also combines with each other, then they will do so in the ratio of their masses. Okay. So here one atom of sodium is combining with one atom of hydrogen, and here one atom of chlorine is combining with one atom of hydrogen. So if Na and Cl also combine with each other and they form compound NaCl. So in NaCl compound, if you see, there is one atom of sodium is combining with one atom of chlorine. Okay. So what is the, here the question is about the masses. So what is the mass of one, you can say 1 mole of sodium, that is equals to its 23, its atomic weight. So it is 23 is to, the chlorine is 35.5. So 23 is to 35.5. This is the ratio of the masses in which the sodium and chlorine, they combine with each other. Okay. So it's not 1:1, it's not 23:1, it's 23 is to 33.5, 35.5. Okay. So A is going to be the correct option. Okay. So this question is also based upon the law of reciprocal proportion that we have seen in the previous question, in the question number 1. Okay. So I hope that you understand the question. So let's move to the next one. Question number 3. How much volume of oxygen will be required for complete combustion of 40 ml of acetylene, and how much volume of carbon dioxide will be formed? And all volumes are measured at NTP, normal temperature and pressure. Okay. So this is the question. So here the question is about calculation of the volume of oxygen required and the volume of CO2 that is formed. So here acetylene is the hydrocarbon, acetylene. So acetylene is what? C2H2. This is acetylene, and this acetylene is undergoing a combustion reaction and it is forming C2H2, is reacting with oxygen, and it will form the products of combustion, that is CO2 along with H2O. But we are not interested in water here, we are only interested in oxygen and CO2. Here 40 ml of C2O2 is C2H2 is taken, acetylene, that is 40 ml. Okay. And we want to find how much volume of oxygen is required and how much volume of carbon dioxide will be formed. So let's first balance this equation. This is not balanced. So if you balance this one, it is 2 carbon, so it is 2. Okay. And if you see, there is 4 plus 1 oxygen, 5 oxygen. So 5 oxygen means it is 5/2. 5/2. Okay. Yeah, this is, now it is completely balanced. So if you see, the 1 mole is reacting with 5/2 moles and it is forming 2 moles. So if you take in volumes, the one volume like 1 ml will react with 5/2 ml and it forms 2 ml CO2. Okay. So but now we are taking 40 ml. So if you take 40 ml, how much oxygen is required? That is 5/2 into 40 ml is required, and 2 into 40 ml will be formed. Okay. So it is 5/2 into 40 is how much? 220 is so which is 100 ml, and 240 is it is 80 ml. Okay. So this is the volume of oxygen required and this is the volume of CO2 formed. So 180. So it is option A is correct one. Okay. Also don't confuse between these two options. Like people, if they got answer 180, without looking at the options properly, they may tick answer B. So here in this question, it is important to see in which order they are asked. It is first volume of oxygen is asked. So volume of oxygen is 100 ml. So this is going to be the answer. Okay. So just don't be hurry even after solving the question in ticking the correct option. Be sure about the order in which they are asked. Okay. So this is question number 3. So next question, move to question number 4. The simplest formula of a compound containing 50% of element X, whose atomic mass is 10, and 50% of element Y, whose atomic mass is 20 is. Okay. So let's decode the question. Let's understand the question first, and after that we'll see how to solve this question. Here the formula is asking in the question, and it is containing two elements. This one is element X and other is element Y. Okay, and the simplest formula of the compound, and the compound contains 50% of element X and also 50% of element Y. Okay, that means the 50% is what? Its mass percentage, and its 50% is its mass percentage. So we have to find what is that formula. Okay, so first I will tell how to solve this question by systematic approach, and I'll tell the shortcut in which you just no need to solve everything. Just by looking at the options, you can get the right one. Okay, so here let's assume that its molecular formula is Xp and Yq. Okay, so and we have to find what is the value of P and Q. That's all. So P we have to find and Q we have to find. Okay, so in this compound, let's see what is the mass percentage of X. That is the mass of X present. That is Px, P into its atomic mass. Its atomic mass is 10. So it is 10P. Okay, divided by the 10P plus atomic mass of Y is 20. So 20Q. Okay, because there are Q atoms of Y. So atomic weight of each Y, that is 20, into there are Q Ys. So 10P plus 20Q. So this is the mass percentage of X, and similarly mass percentage of Y is simply what? 10Q by 10P plus 20Q. Okay. So it is given that this is 50%, that is this is 1 by 2 and it is also 1 by 2. And we have to calculate the two unknowns, one is P and other is Q, two unknowns. So we need two equations. So how to get the two equations? Here it will give you two equations. This is one equation and this is other equation. So it will give two equations, and you can calculate the value of P and Q by solving the two equations. Okay, this is equation 1 and this is equation 2. Both are actually equal. Okay, so if you see one thing, this is Y atomic mass is 20, this is 20, so this is not 10, this is 20Q. Okay, so if you see both are equal, that means this is equal to this one. So 10P by 10P plus 20Q is equal to 20Q by 10P plus 20Q. So 10P plus 20Q, 10P plus 20Q will get cancelled, and what you will get? P you will get, that is equal to 2 times of Q. P is equal to 2 times of Q. Okay, so the P is actually double of Q. So let's see in the options in which P is double of Q. Here P and Q both are equal. Here this is 2 and this is 1. So P is actually double of Q. Okay, so you can blindly select this option because other two are definitely wrong options from this. Okay, so this is the systematic approach to solve this question, and the shortcut I will tell you. So let's see this one, XY. Okay, so in this we will solve this question through the options, given options. So it is XY. Okay, so it is given that it is atomic mass is 10 and its atomic mass is 20. So total the molecular mass is how much? 30, right? Molecular mass of XY is 30. So mass percentage of X is how much? 10 by 30. So which is 1 by 3, but it is given that it is 50%. So you can eliminate this option. And if you see X to Y, so here there are two atoms of X, that is its molecular mass is going to be 20 plus 20, 40. 40 is its molecular mass, and 2X. So mass percentage of X is how much? It is 20 by the total mass is 40. So you will get 1 by 2. That is what? 50%. And X will get 50% and Y will get 50%. Okay, so B is going to be the correct option, and surely these two are going to be the wrong option. So in this way, this is the shortcut to solve this question. Okay, so this is the systematic way and this is the shortcut to solve such kind of questions. Okay, so let's move to the fifth question. A chemical equation is balanced according to the law of, options are multiple proportion, constant proportions, reciprocal proportion, conservation of mass. So this is a pretty simple question. So you can just tick the correct option by looking at the options. So if you see in any chemical equation that is balanced according to the law of conservation of mass, Law of conservation of mass, right? So because we know that from the law of conservation of mass is neither going to be created nor going to be destroyed. It's only converted one form to other. So if you see in a chemical reaction, say suppose A and B is giving, say suppose C and D. So these are the reactants and these are the products. So the total mass of the reactants should be equal to the total mass of the products. Okay. So by this way you will actually balance the equation. You will take each type of atom. If you take say suppose in the reactants you have carbon atoms. So you will see whether on the reactant side how many carbon atoms are there and the product side how many carbon atoms are there. So if they are equal, then you will go to other element. If they are not equal, then you will balance carbons and you balance oxygens, you balance similarly other atoms also. Okay. So that is balancing you're doing from the law of conservation of mass. Okay. Moving to the next one, the sixth question. The large number of molecules is in. This is also very easy question. You can see the large number of molecules is in. So option A, 28 grams of CO. Okay. So first calculate the number of moles. From the number of moles, you can calculate the number of molecules. Okay. Because we know that in one mole we have Avogadro number of molecules. So if more is the number of moles and more number of molecules are going to be present. So let's simply calculate the number of moles of each these molecules and we can decide the correct option. So it is CO. Its molecular mass is how much? Carbon is 12, oxygen is 16. So 28 grams. So 28 grams of CO is actually 1 mole. Okay. So here we have 1 mole which contains Avogadro number of molecules of CO and 46 grams. So carbon is how much? This is 24 plus 5 plus 16 plus 1. How much you will get? You will get 46. So 46 grams. So this is also 1 mole which contains the same number of molecules. 36 grams of H2O. H2O is 18 grams. So 36 grams is actually 2 moles. So you can simply eliminate these two because this is 2 moles and let's see, let's come to D, that is 54 grams. So N2O5, this is 28 and this is how much? Oxygen is 16, 16 5s are 80. So this is 108. So it is actually half mole. Okay. So half mole means only half of Avogadro number of molecules of N2O5 is going to be present. So which option is right? Which contain the large number of molecules, that is having more number of moles, that is surely C. C is going to be the correct option. Okay. So in any case, when these kind of questions are given, just calculate the number of moles. Okay. If you calculate the number of moles, the moles is proportional to the number of molecules. If more number of moles is there, then obviously more number of molecules is going to be present. So C is the correct option. And next question, moving to the next question, question number 7. Question number 7, okay. So the number of molecules in 89.6 liter of a gas at NTP are. The number of molecules you have to calculate and the volume of the gas is given. Volume of the gas is given at normal temperature and pressure. So how to solve this question? We know that at NTP, 1 mole of any gas occupies 22.4 liters. 22.4 liters. Okay. And 1 mole is going to contain Avogadro number of molecules. So how many moles are present in 89.6 liter? So how many moles are present in 89.6 liter? That is simply 89.6 by 22.4 liter, which you will get 4. 4 moles is present. 4 moles of the gas is present. So 1 mole contains Avogadro number of molecules. So 4 mole contains 4 into Avogadro number of molecules. So 4 into Avogadro number of molecules, yeah, this is the correct option. So option D is the correct one. So, okay. So it's a pretty simple question. Just convert this volume into the number of moles and from the number of moles, calculate the number of molecules. Okay. So move to the next one. Question number 8. The total number of protons in 10 grams of calcium carbonate. So if you write the formula, calcium carbonate is CaCO3. We have to calculate the total number of protons in 10 grams of it. Okay. So this question seems to be a different question, because here in this question it is asked to find the number of protons in CaCO3 in 10 grams. Okay. So how to do this? What is the approach to do this? We have to calculate the total number of protons. Okay. So if you see, if I take one CaCO3 unit, how many protons it contains? How many protons it contains? CaCO3 unit. So calcium contains how many protons? 20 protons. And carbon contains 6 protons, because its atomic number is 6, calcium atomic number is 20, oxygen atomic number is 8. Okay, so it is 8 into 3, 24 protons it's going to contain. So this is the total number of protons in one CaCO3 unit. Okay. So don't confuse with Ca plus 2 and CO3 2 minus. Here only the electrons are different, but if you take Ca or if you take Ca plus 2, your number of protons is not going to be changed. They still remain same. They only differ in the number of electrons. So first calculate the number of protons in 1 unit of CaCO3, and let's see how many units of CaCO3 is present in 10 grams. 10 grams. Okay. So we know that CaCO3 molecular weight is how much? 100 grams. 100 grams is its formula weight. Okay. So 10 grams is corresponding to how many moles? How many moles? It is 10 by 100, right? That is equal to how much? 1 by 10, 0.1 mole. Okay. 0.1 mole. And we know that in 1 mole we have Avogadro number of CaCO3 units. Okay. And in 0.1 mole, how many molecules of CaCO3 present? That is how much? It is simply 0.1 into 6.023 into 10 power 23. Okay. So this is the number of CaCO3 units present in 10 grams. Okay. And we know that one CaCO3 unit contains these many number. How many? 26 plus 24, that is 50. 50 protons are there in one CaCO3. So how many protons are there in these many CaCO3 units? Okay. So that you have to just multiply it with 50. You will get your answer. So 50 into 0.1 is how much? 5. So 5 into 6.023. You will get 3.011 into 10 power 24. That is, yeah, this one, 3.0115 into 10 power 24. So these many number of protons are going to present in 10 grams of calcium carbonate. So A is going to be the correct option. Okay. So here the important thing what we have to know to solve this question, you can easily calculate the number of moles and all that, but this thing you have to know, that number of protons in CaCO3 in one molecule of CaCO3, that is 50 protons are going to present. Okay. So this is what the examiner wants to test in this particular question. If you know this one, then this is a pretty simple question, nothing there is in that. Okay. So let's move to the next question. Yeah, a gas mixture of 3 liters of propane and butane on complete combustion produced 10 liters of carbon dioxide. Find the ratio of propane to butane. Find the ratio of propane to butane. So here we have a mixture, that is propane plus butane mixture we have, and it is given that the total volume of this mixture is 3 liters. That is given in the question. Okay. And on complete combustion, this mixture produced 10 liters of CO2 gas, 10 liters of carbon dioxide it produced. So total amount of CO2 produced is equal to 10 liters. So find the ratio of propane to butane. Here we have to find the volume ratio, that's all. What is the volume of propane to the volume of butane? Okay, that's what we need to find here. So here we have to know the combustion reactions. Here propane undergo combustion and butane also undergo combustion. So we have to remember, we have to know the two combustion reactions, and based on the two combustion reactions you can easily solve this question. You can easily solve this question. Okay, so we know you have to know the formula of propane, the molecular formula. Propane contains 3 carbon atoms, so it is an alkane. It is C3H8, and this is C4H10 is butane. So these are the two molecular formulas of these two compounds. And if propane undergoes combustion, C3H8, and it reacts with oxygen and it produces CO2 along with H2O. Okay, so this is one combustion reaction, and other is C4H10 will react with oxygen and it produces CO2 plus H2O. Okay, so here the major thing is balancing. That's what you require here. Balancing. So 3 carbon atoms, so three carbon atoms, and then next balance the hydrogens also, hydrogens and oxygens. Okay, so if you see here, yeah, you can remember one the general combustion equation, that is CXHY plus X plus Y by 4 O2 gives rise to XCO2 plus Y by 2 H2O. Okay, so this is what you need to know. If you remember this one, this is pretty simple. Even if you don't remember this one, you can balance this one at the point of at the examination point only. Okay, so C3H8. So if you see here, just substitute the values. X is I substituted 3 and Y by 2, that is 4 hydrogens. So hydrogens are also balanced, and next is oxygen you need to balance. So total 6 plus 4, 10 oxygens, right? So 10 oxygens, that's what 10 oxygens means 5 O2. Okay, that is 3 plus 8 by 2, you will get 5. Okay, so either you can remember the formula, or if you have trouble in remembering this formula, you can balance at the moment only. So C4 is 4 CO2, and then next balance hydrogens, 10 hydrogens, so it should be 5. Okay, so it is 4 to 8. 8 plus 5 is how much? 8 plus 5 is 13. 8 plus 5 is 13. So 13 means here we have to take 13 by 2. Okay, so this is the balance equations of these two, and it is given that this is the mixture has 3 liters volume. So I assume that in the mixture I have X is the volume of propane, and the 3 minus X is the volume of butane. Okay, so here this is the X, the volume of propane, and 3 minus X is the volume of butane. So if you see, 1 mole will give you 3 moles of CO2, right? Okay, that means 1 volume will give you 3 volume. So X liters will give you how much? 3X liters. So this is the 3X liters, is the volume of CO2 produced from the combustion of X liters of propane. Similarly, here 1 volume will give you 4 volumes. So 3 minus X volume will give you 4 into 3 minus X. 4 into 3 minus X. So this is the volume of here it is given in the question that the total volume of carbon dioxide produced is 10 liters. Okay, so that is how much? 3X plus 3X is produced, the volume of CO2 produced from combustion of propane, plus 4 into 3 minus X. So this is the total volume of CO2 produced, that is 10 liters. So just solve this one. 3X plus 4 3 is 12 minus 4X is equals to 10. So it is 12 minus X is equals to 10. So X is going to be how much? It is 2. So X is how much? X is 2 liters. So what we assume X is the volume of propane in the mixture. So this is, we got it, the propane is equals to 2 liters. So 3 minus X, the 3 minus 2, this is 1 liter. So the volume of propane to the volume of butane in the mixture is equals to 2:1. So 2:1 is this one. D is the correct option. 2:1 is the correct option. Okay. So I'll summarize what I have done in this question to solve what I have done in this question. So I took the propane volume is X, the butane volume will be 3 minus X because the total volume I know, and here the volume of CO2 is given. So try to calculate the volume by taking this much volumes of the propane and butane. So you'll get this one. So from that you will get X value, that is the volume of C3H8, and if you know this one, you can easily calculate the other one. So the question is solved. Okay, so in this way we have to solve this mixture kind of things. Okay, so move to next question, the question number 10. Question number 10, calculate the molarity of HCl of density 1.17 gram per ml. Okay, so here we need to calculate the molarity of HCl. So for that, let's recollect the formula of molarity. Molarity is what? Number of moles of solute divided by the volume of solution in ml into 1000. So this is the molarity. Okay, so here density is given, density of HCl is given. So how we can make use of this density? That we can make use here. Number of moles is what? Number of moles is equals to mass of solute by the molecular mass of solute. Okay, so it is mass of solute, that is mass of HCl divided by the molecular mass of HCl is the number of moles into the volume in ml into 1000. Okay, so if you take volume in liters, you don't need to write 1000, but if you take in ml, you have to multiply it with 1000, because I am taking in ml because the density is given in ml. Okay, to avoid confusion. So if you see, the density of HCl is what? The mass of HCl by the volume. This is the mass of HCl by volume. So the density of the HCl solution is given. Okay, so this is density. So this is density of HCl divided by the molecular mass of HCl into 1000. So the density is how much? The density is 1.17 divided by the molecular weight of HCl is how much? 36. Cl is 35.5, hydrogen is 1, so it is 36.5 into 1000. So if you calculate this one, you will get the answer. So if you calculate this one, you will get approximately 32 molar, you will get 32 molar, that is 32 moles per liter. So this A is going to be the correct option. Okay, so here instead of giving mass of the solute directly, what they will give is sometimes they will give the density. Okay, so even if they give density, that you can make use of density by this one. So the molarity as number of moles by volume. So molarity is also equal to density divided by the molecular weight of solute into 1000. So this is also one other formula, another formula for molarity. Okay, so depending upon which quantity is given, you can use either this one or either this one to solve the question. Okay, so move to the 11th question. 11th question is 112 ml of a gas is produced at STP by action of 0.412 grams of ROH alcohol with methyl magnesium iodide. So the molecular mass of alcohol is, okay, so let's take down the data what is given. So it is given that the solution, it is given that it's a reaction between alcohol and alcohol is certain alcohol, we don't know that one, that is reacting with CH3 Mgl. This is Grignard reagent, the alkyl magnesium halide, it is methyl magnesium iodide, it is reacting and it will form methane gas along with other product, that is ROMGI. Okay, this is other product, but we are not interested, we are interested in methane only. That is given that the 112 ml of the gas is produced, the produced gas is methane. Okay, so here it is given that if you take 0.412 grams, we are getting 112 ml of a gas, and we want to calculate what is the molecular mass of this alcohol. So what is the molecular mass of this alcohol? Okay, so from this reaction, this is already balanced one, so the 1 mole is giving 1 mole of methane gas. Okay, so 1 mole is how much? The 22.4 liters, 22.4 liters, that is 22,400 ml. Okay, this much amount of methane gas is given by 1 mole of this alcohol weighs how much? Its molecular weight, its molecular mass. Okay, so we are getting 112 from this much, this much mass of alcohol. So how much alcohol mass we have to take so that we'll get 1 mole of this one? So that is 22,400 ml. So this gives the mass of 1 mole of ROH, that is the molecular mass of the alcohol. Okay, so the question is done. So 112 we are getting from this much amount. So 22,400 ml will get from how much amount? So that is 22,400 divided by 112 into 0.412. Okay, so this is 112 200s, and if you multiply this one, you will get 82.4 grams. 82.4 grams. This is the molecular mass, the molecular weight of the alcohol taken. So that is 82.4. Option C is the correct one. Okay, so this is a easy question, but what we have to know is in this one is this equation. Okay, so this chemical equation you need to know, and you need to balance this equation, and once you have a balanced equation in your hand, then the rest everything is simple. Okay, so it's also important to remember the equations also. Some equations you need to remember. So let's see the question number 12. Question number 12. The number of moles present in 1 meter cube of any gas at NTP is. We have to calculate the number of moles present in 1 meter cube of any gas. Say suppose I have a container, and this container volume is 1 meter cube, and some gas is there inside this container, and I want to calculate what is the number of moles of the gas present in this volume. This is what I need to calculate. So how can I calculate? If I think at NTP, we know that the 1 mole of any gas occupies how much? 22.4 liters of the volume. Okay, so this is the volume occupied by 1 mole of gas, and so in 1 meter cube how many moles will be there? That's what we need to find out. So how many moles are going to be there in 1 meter cube? Here meter cube is how much? 1 meter cube is 1000 liters. So this is what you have to know. Meter cube is 1000 liters. Okay, so that is, I have to calculate how many moles are there in 1000 liter. I know that 1 mole is there in 22.4. So the number of moles that are there in 1000 liters is how much? 1000 by 22.4. 1000 by 22.4, if you calculate this value, it comes around 66.64. So not 44.64. So 44.64, that is 44.6. Yeah, option C is the correct one. Okay, so this is a simple question. What you have to know is only this one. 1 meter cube is equal to 1000 liters. So this is what you have to know. If you know this one, then it is just a matter of not more than 10 seconds. Okay, move to next question. Question number 13. Let's see question number 13. Which of the concentration terms are temperature independent? Temperature independent. Okay, so molality, mass fraction, mole fraction. Molality is what? The number of moles of the solute present in 1 kg of the solvent. Okay, so here you have to know the definitions of molarity, normality, and even the mass percentage, volume percentage, and ppm, and mass by volume percentage. Okay, so I'll tell the shortcut how to solve this kind of questions. See one thing, temperature, mass is not going to depend upon the temperature. Mass is not going to depend upon the temperature. No matter how much you heat it or how much you cool it, the mass is still going to be the same. But volume is actually dependent upon temperature. Okay, so in any of the concentrations, if volume term is there, then that is going to be temperature dependent, and if volume term is not there, then that is going to be temperature independent. Okay, so this is molarity, volume term will be there, so it's not temperature independent, in fact it's temperature dependent, so not molarity. In molality we don't have temperature term, volume term, so this is temperature independent. The normality is also we have volume term, temperature dependent, and mass percentage also we don't have any volume term, so it is temperature independent. Volume percentage we have volume term, so it is temperature dependent. And similarly in ppm also, this is temperature independent, and mass by volume, this is also temperature dependent. Okay, so here let's see the options: molality, mass fraction, mole fraction. Molality, mass fraction, and even mole fraction also don't have any volume term, so this is also temperature independent. So just A is going to be the correct option. Okay, A is going to be the correct option. So what you can do is you can eliminate the options in which molarity and normality is there. So molarity is there, so you can eliminate this one simply. Normality is there, you can eliminate this one. Okay, molarity is there, you can eliminate this one. So obviously A is going to be the answer. Okay, so in this way you can just do this question without wasting too much time. Okay, let's move to the next one. Question number 14. Calculate the molarity of pure water. We have to calculate the molarity of the pure water. Okay, which you can easily calculate just from the definition of the molarity itself. So molarity is what? The number of moles of solute divided by the volume of the solution in ml into 1000. Okay, or otherwise you can say number of moles by volume. The volume if I take in liters, and mass, number of moles is what? Mass by molecular mass into volume in liter. Okay, so I want to calculate the molarity of pure water. Pure water, if nothing is no impurities are there in it. So what is the mass of water? Here you can take 1 liter of water. For example, you can take 1 liter of water, and since the density is equals to 1, so 1 liter of water weighs 1 kg, that is 1000 grams. 1000 grams, this is the weight of 1 liter of water. So the mass of 1 liter of water is 1000 grams. So mass is taken in grams. You have to take in grams divided by molecular mass of water is how much? It is H2O. So it is 18 into the volume you have taken 1 liter. So 1 liter. Okay. So it is 1000 by 18. 1000 by 18 is how much? 55.5 mole per liter or molar. Okay. So this is the molarity of the pure water, 55.5. So B is going to be the correct option. Okay. So here this is what you need to know. The mass of 1 liter of water is equals to 1 kg or 1000 grams. So if you know this one, this question is a easy one. Let's see the question number 15. Question number 15 is what? The 12 grams of magnesium will react with an acid to give 1 mole of H2, 1 mole of O2, half mole of H2, half mole of O2. Okay. So for this you cannot solve until and unless if you don't know the reaction between magnesium and an acid. Okay. So any acid you can take, like magnesium, if I take the simple HCl, if I take, it reacts with the HCl and it forms magnesium chloride along with the liberation of hydrogen. Okay. So it is, if you balance this one, it is 2HCl. Okay. So since metal, it will react with an acid and it will liberate hydrogen gas. So it's 100% it's not going to be oxygen. So it's B and D you can just eliminate at the moment itself. The moment you see these options you can eliminate. And the question is whether we get 1 mole or whether we get half mole. Okay, there's a competition between A and C. So let's see whether 1 mole is liberated or half mole. So we have taken 12 grams. Okay, so if you see the 1 mole of magnesium will give you 1 mole of hydrogen gas. Okay. So 12 grams of magnesium weighs 12 grams of magnesium is how many moles? It is 12 by 12 by 24, that is half mole. So 0.5 mole will give you 0.5 moles of hydrogen. Okay. So half mole of hydrogen you will get. So this is also a very simple question. Okay. Instead of 12, if you take 24 grams, you would have got 1 mole of hydrogen. Okay, but you will get only hydrogen, you don't get oxygen. So you can easily eliminate these two and you can calculate the moles of hydrogen which is liberated. Okay. So let's see the next question. So which of the following samples contains largest number of atom? Okay. So whenever questions came from largest number of atoms or molecules, just calculate the number of moles. That is the idea to solve such kind of questions. So 1 gram of nickel, okay, 1 gram of nickel, that is 1 divided by nickel, its atomic weight is how much? It's 59. Okay, so 1 by 59 moles. And if you take the B, that is 1 gram of calcium, that is 1 by calcium atomic weight is how much? 40. So 1 by 40 moles. And 1 gram of N2 is how much? 1 by N2 is 28 mole. This is 1 by 28 mole, and this is 1 gram of boron. So this 1 gram divided by the boron atomic weight is 11. So 1 by 11 mole. So let's see, largest number of atoms is what? The one which has more number of moles. Okay, more number of moles. So in these 4 options, let's see which quantity is greater. So it is actually 59. So 59 means it's less quantity. We have 1 by 11. Okay, so you can eliminate this one because this is small, and 1 by 40, this is also small, and this 1 by 28 and 1 by 11. Okay, so some people may commit a mistake here. These are actually atoms, but this is a molecule. Okay, so but each molecule contain 2 atoms. Okay, so 1 by 28 mole contains 2 into 1 by 28 atoms of nitrogen. So it's not 1 by 28, it's 2 by 28, because in the question it is asked about atoms. So it is 1 by 14. Okay, so 1 by 14, but still this value is actually greater as compared to 1 by 14 also. So 1 by 11 is greater. Okay, so D is going to be the option. So D is going to be the correct option, which will contain more number of atoms, largest number of atoms. Okay, so let's see the question number 17. Question number 17, if you see, how many grams of NaOH will be needed to prepare 250 ml of 0.1 molar solution? 250 ml of 0.1 molar solution. So let's write the data given. You have to calculate the mass of NaOH required. That is what we need to calculate. And what we have, what is given in the question, the volume of the solution is given, and that is 250 ml, and its molarity is given, that is equals to 0.1 molar. Okay, so let's write the definition of molarity and let's calculate the mass. So molarity is equals to what? Mass of NaOH divided by its molecular mass into its volume in ml into 1000. Okay, so mass, this is what we need to calculate, and mass divided by molecular mass of NaOH is how much? It is 40. Okay, it is 40 into volume is given, that is 250 into 1000, and the molarity is given as 0.1. So everything we know, only mass is one unknown. So 251, this is actually 1000. So 254, 4 ones, 4 tens. Okay, so mass is how much? 10 into 0.1, that is 1 gram. 1 gram of NaOH actually required to prepare 0.1 molar solution having a volume 250 ml. So 1 gram is going to be the answer. Okay, so it's a very easy question. Just write down the formula and everything is given. Just do the calculation and get the answer. So let's move to the next question. The number of neutrons in a drop of water. 20 drops is equal to 1 ml at 4 degree centigrade. Okay, this is what the question is. Here the question is a different one because it is asked to find the number of neutrons. Before we solved a question in which we calculated number of protons, but we have to calculate the number of neutrons in a drop of water at 4 degree centigrade. Okay, so for that what we can do, here 20 drops is 1 ml, but here only 1 drop. So 1 drop is how much? It will be 1 by 20 ml. 1 drop is going to have volume 1 by 20 ml. Okay, and we have to calculate the number of neutrons. So we know that water is made up of H2O molecules. So let's see, first let's see how many neutrons are there in one molecule of H2O, and from that, if you know the number of water molecules, you can just multiply it with the number of neutrons in each one, then you will get the total number of neutrons, right? So in H2O, H2O is formed by hydrogen and oxygen. Hydrogen, it's a protium, so it does not have any neutrons. So hydrogen does not have any neutrons, but oxygen is O816. Okay, so the number of neutrons are how many? 16 minus 8. Okay, so in H2O we have only 8 neutrons. In one molecule of H2O we have 8 neutrons. So let's calculate how many H2O molecules we have in one drop. Okay, so for that what we can do is, we know that one 1 mole of H2O, it weighs 18 grams, right? So in 18 grams we have Avogadro number of H2O molecules. Okay, so in 1 by 20 ml, okay, 1 ml is what? 1 ml is 1 gram of water. So 1 by 20 gram contains how many molecules of water? Okay, so this will give you the number of water molecules in one drop. So this is equal to Na into 1 by 20 into 1 by 18. Okay, this is the number of water molecules which you will get, a particular some quantity, and that will get is 0.016 into 10 power 23 will get roughly. Okay, this is the number of water molecules, and but each water molecule contain 8 neutrons. So total number of neutrons is how many? This quantity into 8. Okay, this quantity into 8. If you solve this one, you'll get 1.338 into 10 power 22 neutrons will get. That is 1.338 into 10 power 22. So B is going to be the correct option. Okay. So here what you need to know is the number of neutrons in one water molecules, and how you can calculate the number of water molecules. Okay. You can use this way, you can calculate that one. Now let's go to the next question. So question number 19, if you see, the question number 19 is, assuming that petrol is octane C8H8 and has a density of 0.8 gram per ml, 1.425 litre of petrol on complete combustion will consume. So this question is also based upon the combustion. So in combustion questions, if you know the balance equation, you can easily do it. Okay. So this is octane is given. So octane is C8H18. And its density is given. Its density is 0.8 gram per ml. Okay, and this is the volume of the petrol is given, that is octane. Volume is 1.425 liters. If I convert it into milliliters, it is 1425 milliliters. Okay, so let's write the balance equation, and from the balance equation you can calculate oxygen volume. So this is C8H18 plus O2 is giving you CO2 plus H2O. First balance carbon, 8 carbons, so it should be 8. Okay. So next hydrogens, so it is 18, so it should be 9. Okay. And if you see, it is a total 18 to 16 plus 9, how many? 25. So 25 means it should be 25 by 2. Okay. So 1 mole will require 25 by 2 moles. Okay. And if you see how many moles of octane we have taken actually, so 1 mole will require 25 by 2 mole, and you can calculate the moles of C8H18 by this density. Okay, so the volume, we know that mass is equals to density into volume, right? So density is what? 0.8 gram per milliliter into volume in milliliters. So don't directly substitute in liters, you will get wrong answer. So you will get 1425. This is going to be the mass in grams of octane, and that you will get 1140 grams you will get if you calculate this one. This is the mass. So you can calculate the number of moles. So this is 12 8s 26, 12 8s 96 plus it is 18. So this is actually 114. So this is its molecular mass. So 1140 by 114, that is 10 moles. Okay. So 10 moles will require how many? It requires 10 into 25 by 2, right? So how much this is? 2 1s are 2 5s are 25 5s is 125 moles of oxygen you actually require. 125 moles. So option D is the correct one. That is 125 mole of oxygen you require for the complete combustion of 10 moles of C8H18, that is octane. Okay. So here just calculate the number of moles and use the balance equation to get the answer. Okay. So move to question number 20. What is the question number 20? 8 grams of O2 has the same number of molecules as in. Okay. So number of molecules. So first calculate the number of moles. So 8 grams of oxygen is how many moles? 8 by 32, that is equal to 1 by 4 mole. Okay. So let's see, out of these options the number of moles are equal to 1 by 4. 7 grams of CO is 12 plus oxygen is 16, so it is 28. Okay, mass is mass is 7 by 28 is 1 by 4. Okay, so you're getting 1 by 4 in this case. So 1 by 4 it contains same number of molecules, and let's see, it is 14 grams, so it is 14 by 28. This is only half mole. Okay, and this is how many? It's 28. This is 1 mole, and this is, you'll get some other thing. Okay, but so number of moles are equal only in this case, so the same number of molecules also they are going to contain. So A is going to be the correct option. Okay, now let's see the question number 21. In the reaction, the ratio of volumes of nitrogen, hydrogen and ammonia is 1:3:2. These figures illustrate the law of. Okay, so let's see what is given. It's the ratio of volume of nitrogen, hydrogen and ammonia. The nitrogen and hydrogen react together and they form ammonia. So here the ratio of volumes of nitrogen. Nitrogen is one volume. So N2 plus 3H2 gives us to 2NH3. Okay, that is 1:3:2. These figures illustrate the law of constant proportions, Gilus-Salk, multiple proportion, reciprocal proportion. So if you observe here, it is about the law of combining volumes. One volume of N2 combined with 3 volume of H2 and it forms 2 volume of NH3. So these figures they definitely illustrate the Gilus-Salk's law of combining volumes, right? It's nothing to do with constant proportion, multiple proportion, reciprocal proportion. So it is the figures, the numbers, they simply illustrate the volume in which they combine and they form. Okay, so it is definitely option B. Option B is going to the correct option, that is Gilus-Salk's law of combining volumes. Okay, so let's move to next question. This question, a weight of one atom of an element is 6.644 into 10 power minus 23 grams. What is the number of atoms of element in 40 kg of it? So let's write what is given in the question. It is given that the weight of one atom of an element. So here an element is taken and that one atom of an element weighs. So one atom of element is weighing 6.644 into 10 power minus 23 grams. So this is the weight of one atom. So what is the number of atoms of element in 40 kg of it? We need to find how many atoms are there in 40 kg. 40 kg sample of that element is taken and we have to calculate how many atoms will be there in 40 kg of that element. Okay. So how to do this? How we have to approach this question? So this is the weight of one atom, right? So let's see, Avogadro number of atoms weighs how much? So that is the weight of Avogadro number of atoms is equal to the weight of Avogadro number of atoms is equal to Avogadro number, that is 6.023 into 10 power 23 into these many atoms are there in 1 mole and each atom weighs this much, that is 6.644 into 10 power minus 23. So these two will get cancelled and how much you will get? This value you will get around 40 grams. 40 grams. So 40 grams it is the weight of 1 mole of atoms. That is 1 mole of atoms, right? So 1 mole of atom weighs 40 grams. So we want to calculate how many atoms will be there in 40 kg. Okay, so in 40 grams Avogadro number of atoms is there. So in 40 kg, that is 40,000 grams, how many atoms will be there? Okay, that is simply what? That is simply 10 cube into Na. 10 cube into Na. So these are the number of atoms in 40 kg of that element. 40 kg of that element sample. That is 1000 into Avogadro number. So let's see options. 10 cube gram atom, 10 square gram atom, 10 power 4 gram atom and 10 gram atom. Okay. So instead of directly giving Avogadro number, here they have given gram atom. So this is just to confuse, like many students, they don't know what is gram atom is. So gram atom is nothing but it is that 1 mole, that is Avogadro number of atoms, right? So the mass of Avogadro number of atoms is what? It's atomic mass or atomic weight, that is also known as gram atomic mass, right? So gram atom is nothing but it is Avogadro number. So 10 cube gram atom, this is the number of atoms, that is 10 cube into Avogadro number, that is 10 cube gram atom is the number of atoms in 40 kg of it. Okay, so this is option A is the correct one and all others are wrong. Okay, so here what we have done, we have calculated the mass of Avogadro number of atoms, and from that we got how many atoms are there in 40 kg of it. Okay, so remember here gram atom is nothing but Avogadro number. So moving to the next one, 23rd question. Let's see what it is. A compound contains 3.2% of oxygen. So the minimum molecular weight of the compound is, the question seems interesting one. It's a different question. So let's see how we can solve this question. What is the idea to solve this question? How you can tackle these kind of questions? A compound contains, say any compound, that compound is containing 3.2% of oxygen. 3.2% of oxygen the compound is containing, and we have to calculate the minimum molecular weight of the compound. We want to calculate the minimum molecular weight of that compound. Okay, so here the approach to solve this question like this. See, 3.2% means what? 3.2% means if I take 100 grams of that compound, that 100 grams of that compound is containing 3.2 grams of oxygen. Okay, the 100 grams of the compound is containing 3.2 grams. That's why its percentage is 3.2%. Okay, so this is one thing that we can understand from this percentage, and the minimum molecular weight of the compound. So here is the logic. The logic of the question lies here. The logic behind this question is, see, this is the mass of oxygen in 100 grams of it. We want to calculate the minimum molecular weight of the compound, right? So to calculate the minimum molecular weight, how we can calculate that? We can calculate that, see, in the minimum, the molecular formula of the compound should contain at least one oxygen. At least one oxygen, right? Because there is only one atom of oxygen exists. There is nothing like half atom of oxygen and 3/4 atom of oxygen. So minimum we have only one atom of oxygen, right? So the compound, when it contains only one atom of oxygen, then that compound is going to have the minimum molecular weight, right? So what is the mass of one atom of oxygen? One atom of oxygen is what? It is 16 grams, right? 16 grams. Okay, so 3.2 grams is present in 100 grams of the compound. So 16 grams will present in how many grams? This gives the minimum molecular weight, that is containing one oxygen. Okay, so how much this value will become? It is 100 into 16 by 3.2, right? So how much it will be? 100 into 16 by 32 into 10. 3.2 is what? 32 by 10. So 16 2s are 2 1s are 2 5s are, so it is 500. 500 is the minimum molecular weight of the compound. Okay, so this is how we have to solve this question. Okay, so instead of 3.2, they may give you any other percentage. Okay, say suppose if they give you 5% of oxygen. Okay, so that is 100 grams of the compound containing 5 grams. So how much what will be its minimum molecular weight if it contains 5% oxygen? So if it is 16 grams. Okay, so 5 grams is present in 100 grams. So 16 grams is present in how many grams? So that will give the minimum molecular weight of the compound. Okay, so this is how we can solve this question. This is the approach to this question. Okay, I hope that you understand the logic behind this question. Let's move to the next question. Question number 24. Arrange the following in the order of increasing mass. in the order of increasing mass. First option is 3.0115 into 10 power 23 molecules of white phosphorus. Second is 10 moles of hydrogen gas. Third is 1 gram molecule of anhydrous Na2CO3. And fourth is 33.6 liters of CO2 gas at STP. These are the four options, and we have to arrange in the order of increasing mass. Okay. So let's calculate the mass in each case, and then we can easily arrange that, right? So let's take the first case. It is 3.0115 into 10 power 23 molecules of white phosphorus. Okay. So white phosphorus is what? It is P4. Atomicity of phosphorus is 4. This is the white phosphorus molecule. And we have these many molecules of white phosphorus. So what it will be? Its mass. So if you take the phosphorus, atomic mass is 31. Okay. So the molecular weight of phosphorus is 31 into 4. That comes 124 gram. 124 is the its molecular weight. 4 ones are 4, 4 is the 12. 124. Okay. So here this is actually what? This is Avogadro number by 2. Avogadro number, half of Avogadro number molecules. So Avogadro number of molecules weighs 124 grams. Then half of Avogadro number of molecules weighs how much? Half of this value, that is 62 grams. So 62 grams is the mass of these many molecules of white phosphorus. Okay. So this is 62 grams. And let's see mass of 10 moles of hydrogen gas. 1 mole of hydrogen gas is what? 2 grams. So 10 moles is 10 into 2, that is 20 grams. This is simple. And third one, see the third one, 1 gram molecule of anhydrous Na2CO3. 1 gram molecule of anhydrous Na2CO3. Anhydrous means it's not containing any water molecules. Anhydrous Na2CO3 and 1 gram molecule. So what is 1 gram molecule? So most of the students, they don't know what is 1 gram molecule. So this is where they cannot solve this question. So 1 gram molecule is nothing but it's 1 mole. 1 mole of anhydrous Na2CO3. That is its molecular weight, that's all. 1 mole of NO2CO3 is nothing but its molecular weight. So its molecular weight is how much? It is nitrogen is 23. 23 into 2 is 56. Plus carbon is 12. Plus oxygen is 16, 3, 48. So it is, if you see how much this value will become, 23 2s are 46, sorry, it is 46. So it is 60 plus 46, 106 grams. Its molecular weight is 106. Okay. So 1 gram molecule is nothing but 1 mole. So 1 mole of anhydrous Na2CO3 weighs 106 grams. That is the third one. And fourth one, let's see, 33.6 liters of CO2 gas at STP. Okay. So we know that at STP, CO2 gas, 22.4 liters of CO2 gas is corresponding to 1 mole. So 1 mole of CO2 is 44 grams, right? So 22.4 liters is 44 grams, then 33.6 liters is how much? So that will give the mass. So it will be simply 33.6 into 44 by 22.4. This ratio will be 3 by 2, 1.5. So 3 by 2 into 44 will give you how much? 66 grams. 222, so 66 grams. So this is 66 gram. So just arrange this one in the order of increasing the mass. The least one is hydrogen. This is, so second is the least one, and next is 62 is the one. So that is 2, 1, and next is this one 66, that is 4, and highest one is 3. So this is the answer. So let's see which option is correct. 2 will, 2, 1, 4, 3. 2, 1, 4, 3. This is 3 being the highest mass, and after that 4, 66, and after that 1, 62, and 2, 20. So A is going to be the correct answer. Okay. So also please carefully see the options. Don't confuse. Don't get confused. though if you solve till here, but if you have a confusion in selecting the correct option, then your marks are gone. Okay, so you should be careful at each and every point. At all the time you should be careful. So moving to the next one, the question number 25. The number of oxalic acid molecules in 100 ml of 0.02 normal oxalic acid are. Okay, here we have to calculate the number of oxalic acid molecules. Okay, number of oxalic acid molecules in volume is given as 100 ml and its normality is given as 0.02 normal. Okay, and in this solution we have to calculate how many oxalic acid molecules are there. Okay, so how to do this? So number of molecules you can calculate if you know the number of moles, right? So if you can able to calculate the number of moles, then the question is done. So let's see how we can try so that we'll get the required one, that is the number of moles. Okay, so here let's use make use of these two quantities which are given, volume and normality. Okay, so if you see, molarity is what? Molarity is number of moles divided by volume of the solution in ml into 1000, right? So this is the molarity. So if you can able to calculate molarity and we already know this value, we can calculate the number of moles, right? So this is the idea. So number of moles you can calculate if you know the molarity, but we know normality. We want to know molarity. How you can calculate the molarity from normality? Okay, so if you recollect, we have an expression like normality is equals to molarity into n factor, right? Molarity into n factor. For oxalic acid, since it is a dibasic acid, so its n factor is 2. So its molarity is what? Its normality divided by 2. So this is normality 0.02. So its molarity is going to be 0.01, right? 0.01 molar. Okay, so if you multiply this molarity with volume, we'll get the number of moles. So volume is 100 ml. So volume is 100 ml. So 100 into 0.01. This is how many? 10 square 10 power minus 2, 1. You will get 1. Okay, so this 1 is actually millimoles, not moles. Millimoles. Okay, since you are taking that volume in milliliters, so volume in milliliters, molarity, so this is equal to what? The 1 millimole. 1 millimole we have. Okay, so since we know millimoles, we can calculate the number of moles. Number of moles is how much? Number of moles is simply 10 power minus 3. Number of moles is 10 power minus 3. Okay, so 1 mole, we know that 1 mole contains Avogadro number of oxalic acid molecules. So 10 power 3 moles contain how many? So this is what we are looking for. So what is the answer will become? It is simply 10 power minus 3 into Avogadro number. Okay, so it will be 6.023 into 10 power 23 into 10 power minus 3, right? So this will be simply 10 power 20. So 10 power 20, yeah, this is 10 power 20. So you can blindly put this option. Okay, so A is going to be the correct option. A is the correct option. Okay, so if you see in this, how you are able to solve this question here. For calculation of the molecules or atoms, you require moles. Okay, so you have to see how you can obtain the number of moles from the given data. That is where your intelligence plays a role. How you can get the thing that is required from the given data. If you understand that one, then the question is pretty simple one. Okay, so this is question number 25, and let's move to the next question. 26 one. Arrange the following in the order of decreasing mass. So 1 fluorine atom, 1 nitrogen atom, 1 oxygen atom, and 1 hydrogen atom. So we have to arrange this one in the order of decreasing mass, decreasing their mass. So let's see, let's go one by one, do systematically. Okay, so 1 fluorine atom mass we have to calculate, right? 1 fluorine atom mass. If you recollect, what is the atomic weight of fluorine? Atomic weight of fluorine is 19. 19 is the atomic weight of fluorine. So what does atomic weight represents? Atomic weight is simply the weight of, it is the mass or the weight of Avogadro number of fluorine atoms. Okay. So Avogadro number of fluorine atoms into mass of each fluorine atom. Mass of each fluorine atom. If you calculate this value will be 90. Okay. So this is atomic mass, atomic weight, Avogadro number into mass of each atom. So we want to calculate one fluorine atom mass. So we want to calculate this one. It will be simply 19 by Na. 19 by Na is going to be the mass of one fluorine atom. Similarly, you can calculate the mass of other atoms also. The second one is what? One nitrogen atom. One nitrogen atom. It will be, see, its atomic weight is how much? Nitrogen is 14 by Na. It will be the mass of one nitrogen atom. And third one is what? Third one is one oxygen atom. One oxygen atom is equals to, it is oxygen is 16, right? 16 its atomic mass divided by Avogadro number, that is 6.023 into 10 power 23. And the fourth one is one hydrogen atom. So one hydrogen atom is 1 gram, and this is atomic weight divided by Na. Okay. So we have 4 values. Just we have to arrange these 4 values in the decreasing order, in the order of decreasing mass. So which one is higher value? Which one is a higher value? If you see, in all these, the denominator is same, Na. Okay. So the value will be high if numerator is high. So this is the first one. Okay. This is the highest mass. So 1 is highest, and after that oxygen 3 is the second highest, and 2 will be the third highest, and fourth will be the least one, right? So 1, 3, 2, 4. So 1, 3, 2, 4. Which is right? So C. C is the correct one. Okay. So this is how you can solve this question. Okay. So remember that here one thing you need to remember is atomic weight is actually, atomic mass or atomic weight is equal to the mass of Avogadro number of atoms. If you know this thing, this problem, you can easily solve. Mass of Avogadro number of atoms. There may be atoms, maybe fluorine atom, maybe oxygen atom, it may be hydrogen atom. Okay, it may be any atom. So moving to the next question, 27. 27 is what? The number of millimoles contained in 0.16 grams of NaOH is. Okay, the question is, I think, very simple one, right? The number of moles, you have to calculate the number of millimoles, not moles. Okay, so pay attention to this one. Mass is given as 0.16 grams, and you know its molecular mass of NaOH is 40. Okay, so its number of moles is equals to its given mass 0.16 by its molecular mass 40. If you calculate this one, you will get 0.04. This is the number of moles. Okay, so 0.04 is the answer. So if you think like 0.04 is the answer, then you're wrong, because in this question it is asked to calculate the number of millimoles. This is actually moles. Okay, so millimoles is how we can calculate the millimoles. It is actually 0.004 you will get. How much you will get? Okay, let's try to calculate this one. It is 16 divided by 100, right? 16 divided by 100 into 40. How much you will get? It is 4 ones, 4 fours. So it is 4 by 1000, 4 by 1000. So you will get actually 0.004 you will get. Okay, it's not 0.04, it's 0.004 is the correct one. This is not the right one. So this is actually number of moles. Okay, number of moles, but here it is asked to find the millimoles. So millimoles is what? 4 millimoles. Convert the moles into millimoles. That you need to just multiply this thing with 1000 to get in millimoles. So that is 4 millimoles is going to be your answer. C is the correct option. Okay, so like if I give you two options, like one option is 0.004, other option is 4. So most of the people, what they'll do is, in the tension, they simply they look for 0.004, and if they find out that, they simply tick that. Okay, so that is wrong. So you have to pay attention what is asked in the question. Okay, so this is how the students commit silly mistakes and they lose too many marks. Okay, so you have to do minimum mistakes, then only you can able to score more marks. Okay, so always topper is the one who will do minimum number of mistakes. Okay, so moving to the next one, 28. 10 ml of liquid carbon disulfide whose specific gravity is 2.63 is burned in oxygen. Find the volume of the resulting gases measured at STP. Okay, so to do this question, you have to know the reaction, right? The reaction between carbon disulfide and oxygen. What are the resulting gases produced? So this is the primary thing you have to know here. If you don't know this one, then forget about the question. So CS2 plus O2, it produces CO2 gas along with SO2 gas. Two gases it produces. So let's balance this equation. Okay, so if you balance it, it is 2 sulfurs, so it should be 2 sulfurs are balanced, and let's balance the oxygens. So 4 oxygens plus 2, 6 oxygens, so it should be 3. Okay, so carbon is balanced, sulfur is balanced, oxygen is also balanced. So this is the chemical reaction. It is given that we have taken 10 ml of this carbon disulfide, 10 ml we have taken, and whose specific gravity is given as 2.63 is the specific gravity. Okay, so we have to calculate volume of the resulting gases. So this is a gas, and we have to calculate the volume of this mixture, volume of the resulting gases at STP. Okay, so how you can do this? First, understand the stoichiometry of the reaction. Here 1 mole is giving 1 mole of CO2 and 2 moles of SO2, right? So if you take 1 mole, so you will get 1 mole plus 2 moles. So totally you will get 3 moles of the resulting gases if you take 1 mole. Okay, so let's see how many moles of CS2 we have taken. For that, we have to calculate the mass of CS2. To calculate the mass, use this specific gravity and this volume. Okay, so if you recollect, what is specific gravity? Specific gravity is, it is the density of that CS2 divided by the density of water, is the specific gravity, which is given as 2.63. So density of CS2, we have to calculate that. Density of water is how much? Density of water, if you take in ml, that is 1 gram per cc. 1 gram per ml is the density of the water. So bring this density of water to this side, which is 1. If you multiply it with, you will get 2.63. So 2.63 gram per ml is the density of carbon disulfide. Okay, so you know density, you know volume, you can calculate the mass, right? So mass is what? Mass equal to density into volume. So density is 2.63 gram per ml into volume in ml, that is 10. So this is 26.3 grams. 26.3 grams of CS2 you have taken. 26.3 grams we have taken, and we have to calculate how much volume of these two gases form by burning this 26.3 in oxygen. Okay, so 1 mole of CS2 is how much? 1 mole of CS2 is carbon is 12, sulfur is 32. So 64 plus 12, that is 76 grams. So 76 grams will give us 3 ml of the resulting gases. So 26.3 will give us how many moles of the mixture? That we can calculate it, right? So 26.3 into 3 divided by 76. So this value will come approximately close to 1. 1 mole you will get. 1 mole of the mixture you will get. So 1 mole of the mixture is how much? 1 mole of the mixture at STP occupies 22.4 liters. 22.4 liters is the B is the correct option. Okay, so B is the correct one. Okay, so here what they have given, the twist in the question is they can directly give us density, but instead of directly giving density they have given specific gravity. So if you don't know the definition of specific gravity, you cannot do this. So this is a barrier to solve this question. So this is one barrier to solve this question. Even this reaction, if you don't know this reaction, you cannot solve this question. Okay, so for every question that there are some barriers. So if you are comfortable overcoming those barriers, you will end up getting the answer. Otherwise you will stuck in middle and you lose your marks. Okay, I hope that you understand this question. So let's move to next one, the 29th one. So 29th one, if you see, the specific heat of a metal of atomic mass 32 is likely to be. We have a metal that's atomic mass is 32. Atomic mass of the metal is 32. So we have to calculate its specific heat. We have to calculate its specific heat. So if you recollect, there is a relationship between the specific heat and atomic mass. Specific heat and atomic mass. So specific heat is known as 6.4 by atomic mass. 6.4 by atomic mass. So 6.4 divided by atomic mass is given as 32. So this value will come how much? It is 64 by 32 into 1 by 10. It is 2 by 10, that is 0.2. So 0.2 is going to be the specific heat of the metal whose atomic mass is 32. So 0.2. So this is the answer. Okay. So you can see how simple this question if you know this formula. If you know this formula. If you don't know this formula, then even if you take so much time, you cannot solve this question. It's a simply a direct question based on the formula. Okay. So please do remember this formula. So next question, we'll go to the last question of the basic concepts of chemistry. A compound of carbon, hydrogen and nitrogen contains these elements in the ratio 9:1:3.5. Okay. So if its molecular mass is 108, so what is the molecular formula? We have to calculate the molecular formula, and molecular mass is given, and the compound is containing carbon, hydrogen and nitrogen. So let's do this problem systematically. So one is carbon, other is hydrogen, and third one is nitrogen. Okay. So the first one, it is elements, they are in the ratio of 9:1:3.5, right? This is the ratio this element present. So if you see the carbon, the atomic mass of carbon is how much? It is, atomic number is 6, so its atomic mass is 12. Hydrogen atomic mass is 1 and nitrogen atomic mass is 14. Okay, so this is ratio, and this is the ratio of the elements present, and this column is for their atomic mass. And if you see, if you divide this by this one, so 9 by 12, 1 by 1, 3.5 by 14. Okay, so 9 by 12 comes how much? 9 by 12 is the 3 by 4, 0.75, and this is 1, and this is how much? This comes around 0.25. Okay, so let's find the simplest ratio. Simplest ratio is, you'll get when you divide by the smallest one, that is 0.25. So the simplest ratio you'll get, it is 0.75 divided by 0.25, and this is 1 by 0.25, and this is 0.25 by 0.25. We're just dividing all these things, these 3 by 0.25. So this is 3, this is 4, and this is 1. Okay, so these are the simplest ratio, the number of atoms of carbon present, hydrogen present and nitrogen present. So 3, 4, 1, right? So its empirical formula will be C3H4N1 will be its empirical formula. This is its empirical formula. It is given that its molecular mass is how much? Let's go back to the question. Its molecular mass is 108, right? So molecular mass is 108. So this is its empirical formula. So what is the mass of this empirical formula? It is 3 into carbon is 12 plus 4 into plus 4 plus nitrogen is 14. So this is 36 plus 4 40, 40 plus 14 is 54. So 54 is its empirical formula weight and 108 is its molecular formula. So it's 108 by 54 will give you how much? It will be 2, right? So the molecular formula will be what? Molecular formula will be empirical formula into this number. So this is, if you see, just double these values, C6H8N2. So these are the actual number of carbon, hydrogen and nitrogen atoms present in the compound that has a molecular mass of 108. Okay. So this is, first we have to find the empirical formula, and from the empirical formula you can calculate the molecular formula of the compound when you know this the molecular weight of the compound. Okay. So this is how you can solve this question. So if you see, if I summarize, we have seen like what different kind of questions can be asked in the basic concepts of chemistry. Okay, there are some theoretical questions they may ask you, and most of the questions you will find from this chapter are numerical questions, and those numerical questions are based upon the concentration terms, that is normality, molarity, okay, molality, mole fraction and all that. And there are even some theoretical concepts that we have to concentrate. Okay, we have to know what is atomic weight, molecular weight. Okay, so these things, they are simple, but you have to concentrate more on them because they are confusing. Okay, so how to calculate the number of moles from the given the volume of the gas, or how to calculate the number of moles from the mass. Okay, the number of moles from the mass. Okay, in this way you can see, you can expect a different kind of questions, different wide variety of the questions in basic concepts of the chemistry. As far as when your understanding is good, then you can solve any of the question from this one. Okay, so we have to do wide variety of the questions, we have to cover all different kinds of question, and in this way you can prepare very well and you can be very comfortable in this basic concepts of chemistry. Okay, so if you understand this basic concepts very well, then it makes the rest of the chemistry very simple, very easy for you. Okay, so I hope that you enjoy with the video solutions and you learn how to solve the questions on this particular thing. Thank you. Hope you enjoyed with the video solutions.